Three numbers whose product is the biggest possible from the array. Here's the narration. Here you're given a list of whole numbers, and your job is to pick three of them that multiply together to give the largest possible result. Once you found that trio, return their product. Beginner level, welcome. Let's start gentle. If someone asks for the biggest result from multiplying three numbers, you'd probably grab the three biggest numbers, right? That's a great first guess. But here's a surprise. A negative number is one that's less than zero, like negative number. And when you multiply two negatives together, the minus signs cancel out and you get a positive. So two small negatives can secretly beat the big numbers. Don't worry if that feels strange. We'll walk through it slowly and you'll see it clear. Here's why even experienced people trip on this. The word largest makes us picture the biggest numbers. But being large and giving the biggest answer when multiplied are two different things, once negative numbers are in the list. Remember, multiplying means combining numbers like three groups of 2 make 6. Keep that difference in mind and one example will make it click. Let's be clear on the goal. We get a list of numbers and we choose exactly three of them. The word products just means the result of multiplying numbers together. We want the three numbers whose product is as big as possible. For the list 1, 2, 3, 4, the best choice is 2, 3, 4 because 2 times 3 times 4 equals 24. Nice and simple so far. Here's the natural first idea. Sorting means putting the numbers in order, smallest to largest, like lining up by height. Once they're sorted, take the three biggest and multiply. And you know what? For a list of only positive numbers, this works perfectly. It feels like we're already finished. Now let's test it. Take negative 9, negative 8, 1, 2, 3. The three biggest are 1, 2, 3 and their product is 6. But watch this, negative 9 times negative 8 is 72 because the two minus signs cancel and give a positive. Then 72 times 3 is 216. That's way bigger than 6. This is the whole trick. Two negatives multiplied together become a big positive. Good news, we only need two easy tools. First, sorting, which we already met, just lines the numbers up from smallest to largest, like arranging playing cards in your hand. Second, in the Python language, max is a ready-made helper that looks at two numbers and hands you back the bigger one. That's everything. Take a breath, that's the whole toolbox. Here's the idea I like to call two corners. Once the list is sorted, the winning answer always hides at the two ends of the line. On the right end sit the three largest numbers. On the left end sit the two smallest numbers, which might be big negatives, and we pair them with the single largest number on the right. A candidate just means a possible answer we're testing. So we only ever have two candidates to compare. That's it. Let's write it, one small step at a time. This first line sorts the list. Why bother sorting? Because it pushes the biggest numbers to the right end and the smallest ones, including any negatives, to the left end. Now our two candidates are sitting at spots we can easily reach. That's all this step does, and it's done. Now the two candidates. A quick note, in Python, a spot number like -1 means the last item, -2 means second from the end, and 0 means the very first. So candidate A multiplies the last three, the biggest numbers. Candidate B multiplies the first two, a possible negative pair, by the single largest at the end. Then, return max gives back whichever result is bigger. And that's our answer. Well done. Time to try it yourself? No pressure. Pause the video for a moment. For the list, -5, -4, 1, 2, 3, what will our function hand back? Think about both ends. The three biggest and the two smallest paired with the largest. Take your time, then scroll on when you're ready. Let's see how you did. The three biggest are 1, 2, 3 and their product is 6. But -5 times -4 is 20, since the two negatives cancel into a positive, and 20 times 3 is 60. So 60 wins. If you guess 60, wonderful. If not, that's completely fine. You just watch the pattern work exactly as we planned. Here's another way, just so you know it exists, but our sorting method is perfectly good. Instead of sorting, you can walk through the list one time, and as you go, keep track of only the two smallest numbers and the three largest numbers you've seen. The upside is it can be a little faster. The downside is you're juggling more things at once and it's easy to make a small mistake. For now, our first method is the friendly choice. So which should you choose? People sometimes measure how much work a method does as the list grows. The scanning method does a bit less work, so it's slightly faster on huge lists. But the sorting method is just a few lines that are very hard to get wrong. My honest advice for a beginner, use sorting. On small lists, the speed difference is tiny and not worth the extra worry. Simple and correct beats clever every time. Let's peek at some sneaky cases. What if every number is negative, like -1, -2, -3? The three largest here are the ones closest to 0, and their product is -6. That's actually the best you can possibly do, and our method still picks it correctly. Fun fact, I once wrote a version that only checked the three biggest, and it gave the wrong answer on an all negative list. Oops. Checking both corners quietly handles this for us, and it handles zeros too. Checking both corners quietly handles this for us, and it handles zeros too. Look back at the surprise we started with. The three biggest numbers losing to two negatives. Now you understand exactly why. The winning answer always hides at the two ends of the sorted list. So you check both ends and keep the bigger one. That's the whole idea and you've got it. A new problem drops tomorrow at this same time, where this very same corner trick cracks a tougher one. And truly, reaching the end is the hardest part, and you did it. Tapping like and subscribe is the easy part. See you tomorrow.